On average, men die about 7 years earlier than women, and mammalian rodents and spiders often go belly up before their female counterparts too. One big reason males live shorter lives than females might be hidden away in the chromosomes that help determine sex in the first place. In lots of species, males are more aggressive and take more risks, so you might expect they die first. And in many species, like humans, they do. But males that aren't always more aggressive, and the more aggressive sex doesn't always die first. Instead, when you look across the animal kingdom, the animals that died earlier, regardless of their sex, have something else in common. They have a small sex chromosomes. Sex chromosomes generally come in two sizes, big and small. Part of determines the sex of an individual is the combination of size they inherit. In mammals, like humans, females inherit two big sex chromosomes, while males integrate one big and one small. But in birds, butterflies, and some reptiles and amphibians, the opposite is true. Males get two bigs, while females get a big and a small. In most cases, the sex with the small chromosome tended to die first, regardless of whether they are the males or females. There are two plausible explanations for why this trend exists. One is that having more big sex chromosomes is better, and the other is that having a small sex chromosome is worse. Having more big sex chromosomes might be better because big sex chromosomes have lots of genes on them. A human's big chromosome has 8,000 or so genes that code for many things, unrelated to sex, from color vision to proper adherence to muscular function. Someone with two big chromosomes has two copies of each of those genes. So if one big chromosome carries a harmful mutation, the other is likely to have a working version of the gene. But someone with only one big chromosome only has one copy of all those genes. They have no backup copies. That's why colorblindness, hemophilia, and muscular dystrophy are much more common in human males. While there may be an average to having two big sex chromosomes, there's also evidence there's a disadvantage to having a small chromosomes. Small chromosomes happen to be particularly vulnerable to macular virtual genes called transpositions, which can trigger lots of harmful mutation in genes on other chromosomes. So having a small sex chromosome at all may put a creature at risk for a shorter life. These specialties that big chromosomes are beneficial and that small chromosomes are detrimental are not mutually exclusive. It's likely that both are true. Scientists are still debating how these processes interact and how big a role they play in animals' lifespans versus other factors that may take a while. So if you want to be around when we figure out exactly all this happens, you should probably hope you don't have a small chromosome.